Hello everyone, welcome to today's session. In the last session, we covered a lot of important topics like confusion matrix, probability, types of probability, and so on. Now let's move on and look at our last topic in probability, which is the Bayes theorem. Now guys, Bayes theorem is a very important concept when it comes to statistics and probability. It is majorly used in knife. Those of you aren't aware, now knife Bayes is a supervised learning classification algorithm and it is mainly used in Gmail spam filtering. A lot of you might have noticed that if you open up Gmail, you'll see that you have a folder called spam. All of that is carried out through machine learning and the algorithm used there is knife Bayes. So now let's discuss what exactly the Bayes theorem is and what it denotes. The Bayes theorem is used to show the relation between one conditional probability and its inverse. Basically, it's nothing but probability of an event occurring based on prior knowledge of conditions that might be related to the same event. So mathematically, the Bayes theorem is represented like this, shown in this equation. The left-hand term is referred to as the likelihood ratio, which measures the probability of occurrence of an event B given an event A. On the left-hand side is what is shown as a posterior, is referred to as posterior, which means that the probability of occurrence of A given an event B. The second term is referred to as the likelihood ratio, or this measures the probability of occurrence of B given an event A. Now P of A is also known as the prior, which refers to the actual probability distribution of A and P of B is again the probability of B. This is the Bayes theorem. Now, in order to better understand the Bayes theorem, let's look at a small example. Let's say that we have the three bowls. We have bowl A, bowl B, and bowl C. Bowl A contains 2 blue balls and 4 red balls. Bowl B contains 8 blue balls and 4 red balls. Bowl C contains 1 blue ball and 3 red balls. Now, if we draw one ball from each bowl, what is the probability to draw a blue ball from a bowl A? If we know that we drew exactly a total of 2 blue balls, if you didn't understand the question, please read again. So, I hope all of you have understood the question. Now, what I'm going to do is I'm going to draw a blueprint for you and tell you how exactly to solve the problem. But I want you all to give me the solution to this problem. I'll draw a blueprint. I'll tell you what exactly the steps are. But I want you to come up with a solution on your own. The formula is also given to you. Everything is given to you. All you have to do is come up with the final answer. Let's look at how you can solve this problem. So first of all, what we will do is, let's consider A. Let A be the event of picking a blue ball from bag A, and let X be the event of picking exactly 2 blue balls, because these are the two events that we need to calculate the probability of. Now there are two probabilities that you need to consider here. One is the event of picking a blue ball from bag A, and the other is the event of picking exactly 2 blue balls. So these two are represented by A and X respectively. So what we want is the probability of occurrence of event A given X, which means that given that we are picking exactly 2 blue balls, what is the probability that we are picking a blue ball from bag A? So By the definition of conditional probability, this is exactly what our equation will look like. This is generally an occurrence of event A given element x, and this is the probability of A and x, and this is the probability of x. What we need to do is, we need to find these two probability, which is probability of A and x occurring together, and probability of x. This is the entire solution. So how do you find the P, probability of x? This you can do in three ways. So the first, in blue ball from A, either blue ball from B or red from C. Now first is to find the probability of x. X basically represents the event of picking exactly two blue balls. So these are the three ways in which it is possible. So you'll pick one blue ball from bowl A and one from bowl B. In the second case, you can pick one from A and another blue ball from C. In the third case, you can pick a blue ball from B and blue ball from C. These are the three ways in which it is possible. So you need to find the probability of each of this. Step 2 is that you need to find the probability of A and x occurring together. This is the sum of terms 1 and 2. And this is because in both of these events, you are picking a ball from A. So you find out this probability and let me know your answer in the comment section. We'll see if you get the answer. I gave you the entire solution to this. All you have to do is to substitute the value. Remember that you need to calculate two probabilities. The first probability that you need to calculate is the event of picking a blue ball from bowl A, given that you are picking exactly two blue balls. The second probability you need to calculate is the event of picking exactly two blue balls. These are the two probabilities you need to calculate. So remember that, and this is the solution. Let's move on and get our next topic, which is inferential statistics. So guys, we just completed the probability module. Now we'll discuss inferential statistics, which is the second type of statistics. We discussed descriptive statistics earlier. So like I mentioned earlier, inferential statistics, also known as statistical inference, is a branch of statistics that deals with forming inferences and predictions about a population based on a sample of data taken from the population. And the question you should ask is, how does one form inferences or prediction on a sample? The answer is you use point estimation. Now you must be wondering, what is point estimation? Point estimation is concerned with the use of sample data to measure a single value which serves as an approximate value or the best estimate of an unknown population parameter. That's little confusing. Let me break it down to you. For example, in order to calculate the mean of a huge population, what we do is we first draw out the sample of the population and then we found the sample mean. The sample mean is then used to estimate the population mean. This is basically a point estimate. You are estimating that value of one of the parameter of the population, generally the mean you are trying to estimate the value of the mean. This is what point estimation is. The two main terms in point estimation, there's something known as the estimator and something known as the estimate. Estimator is a function of the sample that is used to find out the estimate. In this example, it's generally the sample mean. So a function that calculates the sample mean is known as the estimator. And the realized value of the estimator is the estimate. So I hope point estimation is clear. Now, how do you find the estimates? These are four common ways in which you can do this. The first one is the method of moments. What you do is, You form an equation in the sample data set and then you analyze the similar equation in the population data set as well. Like the population, mean, population variance, and so on. In a simple terms, what you are doing is you are taking down some known facts about the population and you are extending those ideas to the sample. Once you do that, you can analyze the sample and estimate more essential or more complex values. Next, we have maximum of likelihood. This method uses a model to estimate a value. Now, a maximum of likelihood is majorly based on probability. So, there's a lot of probability involved in this method. Next, we have the Bayes estimator. This works by minimizing the errors or the average risk. The Bayes estimator has a lot to do with the Bayes theorem. Let's not get into the depth of these estimation methods. Finally, we have the best unbiased estimators. In this method, there are several unbiased estimators that can be used to approximate a parameter. So guys, these were a couple of methods that are used to find the estimate, but the most well-known method to find the estimate is known as the interval estimation. This is one of the most important estimation methods. This is where confidence intervals also come into a picture. Apart from interval estimation, we also have something known as margin of error. So I'll be discussing all of this in the upcoming slides. So first, let's understand what is an interval estimation. An interval or range of values which are used to estimate a population parameter is known as an interval estimation. That's very understandable. Generally, what they're trying to see is you're going to estimate the value of a parameter. Let's say you're trying to find the mean of a population. What you're going to do is you're going to build a range and your value will lie in the range or in that interval. So this way your output is going to be more accurate because you are not predicted a point estimation. Instead, you have estimate an interval within which your value might occur. Now this image clearly shows how point estimation and interval estimation are different from each other. So guys, interval estimate is obviously more accurate because you are not just focusing on a particular value or a particular point in order to predict the probability. Instead, you are saying that the value might be within this range between the lower confidence limit and the upper confidence limit. This denotes the range or the interval. If you are still confused about interval estimation, let me give you a small example. If I started, I will take 30 minutes to reach the theatre. This is known as point estimation. But if I started, I will take between 45 minutes to an hour to reach the theatre. This is an example of interval estimation. I hope it's clear. Now, interval estimation gives rise to two important statistical terminologies. One is known as a confidence interval and the other is known as margin of error. So, it is important that you pay attention to both of these terminologies. Confidence interval is one of the most significant measures that are used to check how essential a machine learning model is. So, what is confidence interval? Confidence interval is a measure of your confidence that the interval estimated contains the population parameter or the population mean or any of those parameters. Now, statisticians use confidence interval to describe the amount of uncertainty associated with the sample estimate of population parameter. Now guys, this is a lot of definition. Let me just make you understand the confidence interval with a small example. Let's say that you perform a survey and you survey a group of cat owners to see how many cats food they purchase in 1 year. You test your statistics at the 99% confidence level and you get a confidence interval of 100 to 100. This means that you think that the cat owners buy between 100 of 200 cans in a year. And also, since the confidence level is 99% shows that you're very confident that the results are accurate. I hope all of you are clear with that. Your confidence interval here will be 100 and 200 and your confidence level will be 99%. That's the difference between confidence interval and confidence level. So within your confidence interval, your value is going to lie and your confidence level will show how confident you are about your estimation. I hope that's clear. Let's look at the margin of error. Now the margin of error for the given level of confidence is the greatest possible distance between the point estimate and the value of the parameter that is estimating. You can say that it is the deviation from the actual point estimate. The margin of error can be calculated using this formula. Now ZC here denotes the critical value or the confidence interval, and this is the multiplied by standard deviation divided by root of the sample size. N is basically the sample size. Now let's understand how you can estimate the confidence interval. So guys, the level of confidence, which is denoted by C, is the probability that its interval estimate contains a population parameter. Let's say that you are trying to estimate the mean. So the level of confidence is the probability that its interval estimate contains the population parameter. So this interval between minus ZC and ZC. The area between this curve is nothing but the probability that the interval estimate contains a population parameter. It generally contains the value that you are predicting. Now these are known as critical values. This is your lower limit and your higher limit confidence level. Also, there's something known as the Z-score. Now this score can be calculated by using the standard normal table. If you look it up anywhere on Google, you will find the Z-score table on the standard normal table. To understand how this is done, let's look at a small example. Let's say that the level of confidence is 90%. This means that you are 90% confident that the interval contains the population mean. So the remaining 10%, which is out of 100%, the remaining 10% is equally distributed on these tail regions. So you have 0.05 here and 0.05 over here. So the either side of C, you will distribute the other leftover percentage. Now these Z scores are calculated from the table. As I mentioned before, 1.645 is calculated from the standard normal table. So guys, how do you estimate the level of confidence? So to sum it up, let me tell you the steps that are involved in constructing a confidence interval. First, you would start by identifying a sample statistics. This is statistics that you will use to estimate a population parameter. This can be anything like the mean of the sample. Next, you will select a confidence level. Now the confidence level describes the uncertainty of a sampling method. After that, you will find something known as the margin of error. We discussed margin of error earlier. So you find this based on an equation that I explained in a previous slide. Then you will finally specify the confidence interval. Now, let's look at a problem statement to better understand this concept. A random sample of 32 textbook prices is taken from a local college bookstore. The mean of the sample is x bar equal 74.22 and the sample standard deviation is x equal 23.44. Use a 95% confidence level and find the margin of error for the mean price of all textbooks in the bookstore. Now, this is a very straightforward question. If you want, you can read the question again. All you have to do is, you have to just substitute the values into the equation. So guys, we know the formula of margin of error. You take the z-score from the table. After that, we have deviation reads 23.44 and that's standard deviation, and n stand for the number of samples here. The number of samples is 32 and generally 32 textbooks. So approximately your margin of error is going to be around 8.12, and this is a pretty simple question. I hope all of you understand this. Now you know the idea behind confidence intervals. In the next session, we will learn about the important topics in statistical inferences, which is hypothesis testing, so don't miss that end. And if you have any doubt, just write down your doubts in our comment section. Thank you so much for watching.